Okay, let's begin with the first airspace module, the en route. This module will allow you to simulate traffic during the en route phase. So why using the en route module? Well, we want to assess the traffic complexity and optimize the en route airspace structure. Essentially, with AirTOP en route module, you will be able to create easy to use high fidelity airspace and air traffic models that can be used in a variety of projects, such as capacity studies, for instance, to assess the capacity of the sectors while considering the level of service, the delays. Resectorization and airspace design projects to quickly assess and validate different designs, or for example, to shortlist potential designs before moving to the next validation phases, like real-time simulators. Route optimization and free route implementation. This is an important and very relevant topic nowadays, where many ANSPs are taking the opportunity to redesign and improve the flexibility of their airspaces to better handle the current drop of traffic demand, but also to be prepared for the traffic growth that will inevitably happen. So having more efficient, both economically and environmentally, airspaces, but also reduce vertical separation minima airspaces. These type of projects are aiming at improving the occupancy of sectors while maintaining or improving the level of safety. All of these scenarios, all of these configuration, all of these different type of projects can be modeled and simulated using AirTOP. Why I'm saying high fidelity airspace and air traffic models? Well, the high fidelity comes thanks to the accurate aircraft performance modeling based on BADA aircraft database that you can import directly and keep up to date in AirTOP. Thanks to the airspace infrastructure definition. So it's actually the layout and the static definition of the airspace, but also thanks to the airspace procedures definition. So not only the layout, not only how the airspace is defined, but also how the airspace is actually operated. As any other module of AirTOP, the en route module can be seamlessly be extended to link to the TMA, the flow management, and airside aircraft modules. I'm going to show you some of the most important features of AirTOP en route and AirTOP in general. So the simulation of an AirTOP model consists in defining all the different components, the objects in the AirTOP model, to then run the simulation and retrieve the results. Hence why it's important to be able to define and create these objects efficiently in the AirTOP project. The main data types are essentially two, being that the static or dynamic data. These data can be defined directly on the map, making use of AirTOP user-friendly interface, or imported directly from external file formats such as AXM, shapefiles, Gazelle, which is the export data from Eurocontrol's Nest tool. In this animation, you can see how easy it is to create objects on the map, simply clicking on the menu, selecting the type of object, and then clicking on the map. For example, creating the geographical positions that are going to be used to then define waypoints, ATS routes, sectors, but also special areas, such as military airspaces, restricted areas, and so on. Once these objects have been defined, it is possible to add specific usage conditions. So, for example, specific flight level ranges for different directions of the routes, or the vertical boundaries of a special area. As you can see, in this case, we are creating a polygon directly on the map that is going to be used to then create sectors, making use of the shape of this polygon. Using existing waypoints, existing geographical positions, you can also quickly create ATS routes. And as I mentioned, once you have the objects created on the map, you can start defining what the limitation, what the restrictions are applicable for those objects. This last object is another polygon that is going to be used as a special area. So that can be used as a restricted airspace or a military airspace that can then be activated during the simulation. As I mentioned before, apart from the static data, you're also going to have the dynamic data. Once the static data has been defined, so in other terms, the layout, lateral and vertical boundaries, the dynamic behavior of the airspace can be defined too. In other terms, the procedures, the business rules, the restrictions, essentially the way the airspace infrastructure is operated. The dynamic data, when I'm referring to dynamic data, I'm also referring to, for instance, the rerouting, altitude changes, speed range for different ATS route, and how to adapt all of these restrictions or limitation on how to make use of this airspace infrastructure during the simulation. In this other animation, you can see how additional routes can be defined, starting from existing static data to define, for example, reroutings around restricted areas when these are active. So as you can see, just by clicking on the map, I can create a rerouting that the traffic is going to use when that restricted airspace is active. In this very simple example, a single flight is operated through the sector, crossing a restricted area that hasn't been activated yet. Another powerful feature of AirTOP is to allow you to quickly grow the traffic of the model to simulate multiple flights during the one simulation. Like displayed in the animation, the number of flight plans can be increased with one single action to then show a trail of aircraft crossing the sector and the restricted area. So like you can see in this case, they're all crossing the restricted area because this hasn't been activated yet. By the way, you can also enable or disable some of the labels that are displayed on the map in order to customize the information that you want to see about the aircraft that are being simulated. Now, in this other scenario, we are assuming that the restricted airspace is going to be active for a portion of the time. So the first few aircraft are going to be able to fly through it, but then once it's activated, and you can recognize that by the color red that we are using in the map, the traffic is rerouted to avoid flying through the restricted airspace. Though at a certain point, the special area will be released, so then the last remaining flights can fly through the initial plan, flight plan and the initial route. This feature can also be extended to other use cases, for example, when taking into consideration military bookings, bad weather areas, for instance, CB clouds, or some ATS routes need to be offloaded by spreading the demand over different routes. So there are different use cases that can be reproduced by making use of this functionality. Another very useful feature available in the en route module, as well as in the other AirTOP modules, is the conflict detection and resolution. The main scope is to capture any conflict during the simulation with all its relevant details. For example, the conflict type, the position, the duration, when is occurring, how long it lasts, when it started, when it's ended, and how often these conflicts are occurring in the sector, allowing you to quickly identify hotspots in the sector. So creating heat maps directly in the map by showing where these conflicts are happening more often. In this image, you can see two aircraft, Flight Plan 1 and Flight Plan 2. They're both flying at flight level 300. So that means that by flying in opposite directions, they will be sharing a portion of their routing. That means that inevitably they will have a loss of separation and there's going to be a conflict between the two. You can define when and how you want to capture the conflict. And in this case, I'm setting the minimum separation between two aircraft flying at the same flight level. So the minimum lateral separation of 5 nautical miles. But I'm also setting the minimum separation between the two that cannot be that cannot get any lower than a certain threshold to 10 nautical miles. So then you can see in this picture that as soon as the two aircraft are too close, so less than 10 nautical miles from each other, the conflict is going to be triggered. The conflict event is going to be started. There are additional points in the map. As you can recognize, there are two different type of points, yellow and green. That means that one conflict is going to be, in a way, assigned to flight plan 1 while conflicting with flight plan 2, whereas the second conflict is going to be related to flight plan 2 when conflicting to flight plan 1. So you can really get all of the information about this conflict for each of the aircraft and retrieve all of the statistic and necessary details about what happened, why, and how this could be resolved. This goes to the second feature, not only conflict detection, but also resolution. Once the conflict has been detected, AirTOP can also try to solve it by following a rule-based set of strategies. I'm going to show you what I mean. In this animation, we have two aircraft following their respective routings and having a common portion of routing. In reality, this would probably never happen, as essentially the ATS route would have some limitations in terms of flight level usage, for example, odd or even flight levels when operating in one direction or the other. But in this simple example, just to keep it simple and to show you the conflict, we are disregarding any vertical separation and allowing the aircraft to fly using the very same routing in opposite directions. As you can see, a conflict happened during the simulation, and that was captured and showed in the map. Now, rerunning the same configuration but activating the conflict resolution rule, you're going to see that AirTOP is going to spot a conflict beforehand, therefore asking one of the two aircraft to change its flight level. In this case, it's going to descend to flight level 290 in order to reach the required separation of 1,000 feet between the two. You can define your own set of strategies to avoid the conflict. For instance, instead of using the flight level change, you might want to add a rerouting, path stretching strategy. There are different ways of handling this, but you can also just let AirTOP decide on its own which strategy to adopt in order to separate the two aircraft and avoid the real conflict. You're still going to have the potential conflict detected and captured and logged in the log files, but in this case has been avoided. So the real conflict has been avoided by changing the flight level. Another important aspect of modeling and simulation of the airspace is related to the controller's workload. While the measurement of capacity, delay, fuel burn, and emissions is fairly straightforward, the controller's workload is an abstract and subjective indicator, meaning that given the same demand of traffic in a sector, two different controllers might provide different feedback on their workload. Nevertheless, this measure is a critical factor when defining a sector capacity, as it will need to take into account not only the absolute number of events, so for instance, sector entries or the instant number of aircraft in the sector, but also the occupancy and again, sector entry or occupancy, but also the resulting complexity, so the workload produced on the controllers. Well, AirTOP can help you defining the task that the controller will need to conduct during the simulation based on the events and measure the resulting workload. An important aspect of the workload is that it doesn't grow proportionally to the number of aircraft, as the nature of the traffic mix, the phase of the flights interacting with each other will make the complexity of the workload vary between different scenarios. Like I mentioned, the same number of aircraft could lead to very different levels of workload experienced by the controllers. AirTOP allows you to measure this. It provides evidence when communicating the different levels of service and also communicate these results, which can be otherwise quite abstract to be understood by non-controllers, to pass on the message on how the complexity can really have an impact on the controller workload. And the entry count and occupancy are not the only indicators to really define what the capacity of a sector should be. Everything I have shown you so far All of the interactions, indicators, events, any data produced during the simulation can be retrieved and used. So, for example, creating tables, plots, or exporting it to be used externally. For example, to spreadsheets, SQL databases, or in case you already have your own dashboards, such as Tableau or Power BI, you can even just feed external Python or R scripts you might have already built to analyze operational data. Well, you can reuse all of them, and instead of reading operational data, you will be just analyzing simulated results. So really comparing what the operational results are as opposed to what you are simulating. This can also be used to calibrate your models to make them as realistic and as accurate as possible by comparing them with operational data. Nevertheless, there are hundreds of built-in reports and plots that can be used straight away after the simulation to quickly display and again, to communicate results.